Okay, let's very quickly have a look at the force operator. I won't actually dwell on this in any great detail because the use of forces and the force operator is covered in much more detail in DVD 4 in this series, which is tests, forces and collisions. And as you can tell by the name of that DVD, it deals with three main topics, which are all the tests, the use of forces, and working with collisions in Max. So I'd highly recommend looking at that DVD if you want to get an in-depth description of how forces work. For now, we'll just very quickly run through the force operator, and I'll give you a rough idea of how it works. The force operator is particle flow's interface to the space warp forces that come with 3ds Max. And there are currently 8 forces that work with particle flow, and each has a different effect on your particles, depending on which forces they simulate and also how they are applied to your particles. You can find the force space warps in the creation area of the control panel, and if you go down to space warps here, you can see the first option is forces. You've also got deflectors, which are obviously used for well, it's not very often, it's not very obvious, but they actually are used for collisions. If we go back up to forces, you can see we've got these forces here, and you've got motor, which works with particle flow, vortex works, path follow doesn't, displace doesn't, wind works, push works, drag works, particle bomb works, and gravity works. So you can see that the majority of these actually work with particle flow. In the scene that we've got here, we've actually got some examples of these in action. Here we've got a motor space warp, and I'm just going to make the icon display a little bit smaller on that, and turn off the display of particle effect range so it doesn't take up quite as much of the viewport. This particular space warp has the effect of actually causing your particles to rotate around the axis of the space warp. Up above, you can see we've got a gravity space warp. Over here we've got a wind space warp set to spherical. You can see these both are set to spherical, but they both can actually be planar as well, depending on that tick box. And obviously they'll have different results based on that. And down on the plane, down on the ground plane here, we've got a gravity set to planar, and that's actually used in our particle flow. So I'll show you the simulation without any of these force operators turned on. If I just press play, you can see particles shoot out and they're leaving particle trails behind them. That's just to demonstrate the path of the particles more clearly, because you can actually see their trajectory much more easily when you have these trails being left behind. If I turn on wind and press play, you can see now that there's a little bit of randomness entered into the trajectories of the particles, and wind's actually great for doing that using its turbulence feature. I'll just turn that off. It's actually updating. This is a classic example of probably where a cache operator would be useful. Gravity, we'll turn that on and we'll run the simulation. Now you can see our particles are starting to follow an arc. It's actually this gravity space warp here which has been used. And the last one which you can actually see in action is the motor force. And you can see actually in this one I've used multiple forces. I've used motor and gravity 3. This is gravity 3 here, and this is motor here. And if we run the simulation, you can see that the particles are being twisted around the axis of the motor, and I also think they're being pulled in towards this gravity as well. So yeah, they're actually being pulled back towards this gravity. It's not really strong enough though, so they're basically flying off through space. So that's a quick demonstration of you know, 3 of the forces in action. The way the actual operator works is, I'll just turn this one on again. You have a pick box here where you actually pick